Hello, everybody. Welcome to Houdini Hangout. We are in June now, and glad to have you with us this evening. Tonight, we are going to be looking at some vellum cloth simulation. I think it should be pretty interesting to take a look at. So, hey, welcome. Hey, Baymax, welcome. We are going to look at some kind of interesting stuff that actually Crossfader Lucas has done previously, and I figured, I saw it a couple months ago, and I was like, I want to play around with something like that. So, sounds like so that's what we're gonna do tonight. Hey, Fotis, welcome from Greece. Glad to have you. Nice to have you on the stream. Very nice. iCats, welcome. Glad to have you all. Glad to have you all on the stream this evening. So that is the idea of what we're gonna get up to. I don't really have anything else to maybe talk about before we dive right into some Houdini stuff. I guess everybody's probably seen some of the Houdini 20.5 launch event stuff coming up. So that should be very fun and exciting. I honestly have no idea, but I'm guessing there's going to be a what do you call it? Like a preview, like kind of teaser sometime in the not too distant future. So that should be kind of neat to see some of that stuff. Some of the demos, I think, for new features will be very cool and very interesting for a lot of different reasons. And I've seen some of those being posted internally, and I think it'll be some really neat stuff to see. That's coming up in a couple of weeks here. I know a couple people from my team are going to be heading out to the events in Europe. A Copernicus hint? No. Nope. Sorry, can't do that. But it is named Copernicus, so that's the name of it. I think if you look on if you look out there, I think I've seen some people trying to make guesses as to what it might exactly be. I think there's some hints in some of the teaser images and things like that. So there's some stuff out there to kind of point you in sort of the right direction. If you think about, if you look at what people are saying out there, I think you might find some interesting commentary. So looking forward to that. I think that should be really, really interesting to see all of the launch materials and things like that. It's always fun to get to watch those. We've got that coming up. That should be pretty exciting. And some Annecy presentations that'll be really cool. Can't wait to see those. Some stuff all about character animation. Obviously, we released the Apex rigging tools last release, and that's going to be really neat to see kind of where those continue to move into. Obviously, that was just kind of step 0.5 of what those new animation tools are going to be and how they're going to work. So obviously lots of exciting stuff to come out. If you remember back to the release of Solaris in Houdini 18, that was, kind of the initial foray into that. And, probably it took until about Houdini 19.5 for Solaris to really like hit its stride, I think, in a lot of ways. So, Carlos is asking, does Copernicus come with a Karma Baker? Well, I mean, like, you mean like an oven? Like an oven to put stuff into? Does Copernicus have an oven? Nah, Copernicus did more stuff with like planets and stuff like that. I don't think he was into baking or cooking or anything like that. So I'm going to say I don't think Copernicus was all he was all that interested in baking. So Yeah, well, I guess you'll find out in a couple of weeks. In fact, I might even find out in a couple of weeks some things that I haven't heard about yet. So there's always so much development and new things coming. It's hard to keep up on everything. That's a huge, I mean, obviously, all of us are doing that and trying to learn all we can about what's coming out. So I think that's always a struggle for people. Hey, Zach, welcome. How's it going? I think that's always a struggle, right? Is like, how do you keep up with development and all that kind of stuff? And for me, it's really about picking and choosing my battles, right? Like things that I can learn and can't learn. Um, so, um, so yeah, there's always a lot of stuff that comes out, too much for any one person to be able to all cram into your brain. So, there's some, yeah, we have lots of conversations that surround that internally with the training, the few trainers we have on staff at Side Effects, on the education team, and obviously within our technical consulting teams and things like that. So it's always a struggle to keep up with the pace of development. It's always pretty breakneck. But yeah, so that's going to be really exciting. I can't wait to see all of the release materials and all that stuff. Things, that are, fun examples of new tech that's coming out. So it should be really cool. So anyways, yeah, that's kind of what's coming up on the horizon here, Houdini wise. And I'm a little glad, I'm not going to the event this time, which is great. I was honored enough to be able to go to the launch in London, which was a lot of fun. We also had a ton of school visits, so it was insane, very busy. But this year I won't be traveling to those because honestly, I just have tons of work that I'm doing for stuff that's coming out in the fall for educators and things like that. So we're working on a lot of projects on our team and lots of cool stuff, and I'll be able to share more about that. I'm kind of it's not anything too crazy, but I'm developing some curriculum stuff that's going to help new educators, deliver Houdini and knowledge out there. So probably won't be anything that affects any of you directly, but hopefully we'll have more and more people that know how to teach Houdini better and better. So that's kind of always our goal. But anyways, so yeah, tonight we're going to get into some vellum stuff. I don't know. I'm not super sure of exactly how I'm going to do this, so we'll figure that out. But yeah, so if you guys have any suggestions, questions, comments, anything at all that you want to bring up, feel free to drop it in the chat. I am not I'm not an expert at Houdini. I am someone that has to learn as much as I can professionally, but there's certainly a million different ways of doing things. There's a lot of different ways to to get to these results. So if you guys have thoughts or ideas that you think, hey, maybe this is a better way of doing this, or hey, have you thought about this? Feel free to drop that in the chat. This is an open space to be able to have comments and questions and chat about stuff, and just kind of think about how things are working. And that's exactly what we're here for. No judgment. Obviously, if you're confused about something, someone else probably is as well. So just feel free to drop those questions in the chat as well. So yeah, with that, I guess we will dive in Houdini and get started with some vellum cloth stuff. Hey, Epoxia, welcome. All right, so let me pull up. I clicked the wrong thing. Let me pull up. Get out of there. Let me pull up the thing that I had posted from Crossfader. So Crossfader put this up online. Couple of. Oh, can I pop this out maybe? Oh, that's great. Yeah, that's much better. Then I don't have to keep this open. There we go. So this was his example that he was showing, and I think it's pretty cool. It's got some interesting little elements to it and stuff like that. So I think, well, there's a few different things that we could probably mess around with here, but I think the idea that we should maybe look at is first just getting the pins to work maybe the way we want it to with like a cloth. I think that could be really fun to mess around with. I would really like to do this in a bit more of a maybe with like more of a dimensional, like as opposed to being one flat panel. I'm kind of thinking I might do something that's a bit more do something that's a little bit more thick. But first, I just want to get some of the concepts working, get the cloth to kind of behave the way I'm thinking it maybe should behave, and then we'll sort of go from there. So that's the idea. We're going to do that, and we'll kind of go from there. So I'm just going to pause this, maybe minimize that. All right, cool. Oh yeah, Epoxy, you're saying you did something similar to that before. It wasn't easy to animate attributes inside the solver. Yeah, hopefully we'll be able to do that today in a fairly straightforward way of doing things. Yeah, I think it should work. Hopefully we'll get it to work. It's always the hope. I'll be honest, sometimes it's a real struggle to come on here and be like, I think I know what I'm doing, and try to figure it out live in front of everybody. But that's half the fun, right? For me, at least. All right, so let's do this. We'll do sim. We'll just call this sim flat logo. So we'll just, for right now, do our sim all-in-one geometry thing. We're going to be doing this with SOP-based stuff, so let's do this. Let me do a file node here. I'm going to bring in my logo. I already, hi, Jim Gav. Looks like I got a period from you there. Period right back at you. So I already had the icon for Houdini Hangout. Yeah, so one suggestion, sorry, I'm like banging my desk like crazy today. Sorry if it's shaking my monitor. So Zach, you're saying about attributes inside of solvers. Really the idea here is that there's kind of two things, right? So vellum deals with deals with geometry coming in, right, in a static sort of one time situation. Like it looks at everything coming in, and then that's our starting point for our simulation. Inside of the sim, in our dive target within our solver, that's where we can pull data in to be able to manipulate it live. And that's kind of the two sides of it. I would suggest taking a look at Toadstorm Henry's post from his blog about SOPs and DOPs and like understanding some of what's going on there. It's a really, really good read, and it helps you maybe to kind of split some of the differences between those two a little bit better. So yeah, it can be a little tricky at first, and believe me, I am not, like I said, I'm not an expert at this stuff. So like a lot of it is trial and error for me as well. So hopefully there's not too much error and some trial, but yeah, Vex is often helpful. You could probably use VOPs as well. You probably could do you could do it a few different ways, but certainly Vex can be really helpful, and it shouldn't be too much Vex. So yeah. Anyways, so I'm gonna upload this icon in with the file here so you can see how this works, so this won't completely break. So I'm going to upload that when I upload this file at the end of the stream. But feels pretty hostile from my brain as well, Carlos says. Yeah, I think I think there certainly is some inherent data management stuff you have to kind of think about when you do it. So yeah, maybe in future releases, that'll be maybe a UX thing that happens. I can say this, that I don't think you're going to see any rewrites of anything in 20.5. So I don't think that's don't hold your breath for that anytime soon. That would be a huge rewrite to rewrite how attributes work inside of DOPS. But hey, Ankit, welcome. All right, so let's do a match size. And I'm just going to use that to kind of center this in the right spot here in our scene. I'm also going to do an attribute delete, because when you bring it, so this is actually an Illustrator file. You have to save those out, or it's best to save them out as Illustrator like 8 files or something, whatever the oldest one is, because then you can bring them in really easily. But what this does do, unfortunately, is puts a color attribute on these. So I'm just going to delete that. Unfortunately, this is backwards as well, so I can just reverse this. Throw this down like so. There we go. Reversed. Cool. Not super important, but and these are Bezier curves, so I'm just going to convert this. We can see that here. I'll just show you. So there is what it looked like before, as when it was Bezier. When we convert it, we get quite a few more points here, and you can maybe tweak that a little bit if you would so choose. You can get it, maybe we set it to 1 here. And now we've got a few more points to work with. It certainly isn't great. It's not like really awesome, because these have more points. Like this up here has way too many points. So it's not perfect, but gives you kind of a rough estimate. And that might be just me constructing this poorly in in Illustrator. I am not. Cool. Welcome, Pazark. Welcome from Brazil. Cool. Yeah, so we've got this logo. We could maybe do a resample. Oops, not a rest position. Resample, if I can type. And we'll use that just to kind of get ourselves some more points to work with here. So what I'm going to do, and I think this is probably the best way of doing it, is I'm going to do a planar patch, and I'm going to basically transfer over these points to be pinned. Because a planar patch, hello. I'm not, F Google. Not sure you mentioned it, but maybe do first simulation low res, but backwards with breaking pins. That's interesting. And then resimulate with more details. Yeah, for sure. You could certainly do that. I do think, and it's not, I'm not saying that's not a valid way of doing it. For sure, you could do that. However, I think there will be some telltale signs of that, right? I certainly simulating it at lower resolution and then going up is a good idea. But I think time reversing can introduce visual artifacts that may give away that that's what you're doing. Now, certainly you could do that in a lot of cases, and it wouldn't be too big of a deal. So it certainly is a very valid way of doing it. And a lot of times people do take simulations and time reverse them and stuff like that. In this case, I think I want to do it just forwards, but we'll see. We'll see how, we'll see if we run into some crazy problems, and maybe we will do it that way. I don't know. But that, it's a great suggestion. I just think we might be able to see that. But yeah, definitely low res is always a good suggestion. Don't go too crazy. I think the video that Crossfader did was pretty high resolution. He's got a lot of really nice little folds in there, so I'm guessing he went pretty high resolution on that geometry in the end. So we'll have to kind of find a nice starting point and then go from there. So what I'm going to do is grab a planar patch. Now these are great, because we can make some nice different shapes. I'm going to do a circle. I'm also going to just highlight my logo here. Maybe we'll actually do it the other way, like this. And then we can just kind of change the scale here. I think like 1.2 should be good. And I'm going to go down a little bit in resolution there. I'm just going to find a good starting point here where we could do something like that. Okay, cool. Let's maybe start there, see what we can get up to with that. All right. Nice. All right, let's try that. We can always change the resolution a little bit if we need to. So what I did originally, or I was kind of playing around with this a little just for a minute before I started up, and I think the best way of doing this was is to add a group here to these, and we'll transfer it over. So I'm just going to do a point group here to these points. I mean, obviously we're going to be adding it to all of these because these are the seams that we want to kind of create on this planar patch here. And so let's do a group transfer, and I'm just going to shift click both of these, and that was weird. Thought that should work. Let me try that again. Shift. Yeah, I just hit the wrong one. All right, so we're going to transfer those over. So what we need to do is grab just the point groups. You don't need to look at anything else. Make sure that this is points. I'm going to call this pins. This group pins, and we're going to transfer this over. So let's grab pins, and you might be like, well, that's not working. Well, one of the reasons that this isn't working is because of this distance threshold is set to 10. So if we bring this down, we're going to start to see things change a little here. And so there we go. Things are changing. That might be a little hard to see. Can I enable automatic subtitles? That's an interesting question. I don't know. Actually, I do usually do this as well. So let me just turn this on. Sorry, I usually do this. So this will help a little bit to see what I'm clicking. Automatic subtitles. That's an interesting suggestion. There is a spot on the Discord. I'm just going to post this in here. If you go to HoudiniHangout.com and grab the Discord server, there is a way to, there's a spot on there that I set up for suggestions to enhance the stream. So there's like kind of stream suggestions. What do I call that? Improvements. So I literally, since I opened this Discord, I've had two. One of them I would like to do, but I honestly don't know how to. But or I don't really know a way of automating that. But this is an interesting one, so I would love it if you put it in there. I'm going to look real quick while I'm doing this live. I don't want to belabor the process too much here, but that is an interesting question. Let's see here. Let's go live, and let me just see. Why is my closed captions not available? Let me see here. That's interesting. It's grayed out for me. So I don't know why that is. I would love it if you put that as a suggestion. I honestly hadn't even thought of that before. So that is an interesting suggestion for sure. And I would love to take a look at that when I get some more time. And when I'm not in the middle of doing this. It's actually really tricky to do this. I don't know if anybody's ever tried to do streaming stuff before, but it's definitely not the easiest thing in the world. There's just a lot of stuff to like think through. Anyways, all right, I'm gonna try changing the background here. Hello, wrong thing. That might be better to see. Let me know if that's better or worse. Yeah, I just want to try to get the, let me actually try one more here. Let me just see if I do dark. Oh yeah, that doesn't even change that at all. Probably dark gray. Thanks, Epoxia. So funny enough, while I'm chatting here, in a in what feels like a previous life, I used to do a lot of live production stuff with video. Now, I did directing and things like that. I wasn't like an on-air talent or anything like that, but I've done lots of multicam directing and camera work and different things like that, producing all sorts of random nonsense. And yeah, it's weird. So like, I think that helped, but it definitely is really tough to be doing all of this as one person. But anyways, okay, let's do this. Let me just up the resolution just a little bit, just so we can get a couple more points to be involved there. There we go. That looks pretty good. All right, so that's looking good. So we've got this group transfer over. Hey, Pseudo Kid, welcome to the stream. You're a bit stuck with Houdini. Could I ask a question? Yeah, so you certainly are more than welcome to ask a question here. I can't say that I'll be able to give a good answer now while I'm doing this live, but that is a great thing for Discord, because not only is there me that could answer your question, but lots of other people are there as well. So people jump in there and answer questions and things like that all the time. Oh yeah, that's another thing. I should have it so that it says my Discord on Twitch, because is that a command that works? I don't think so. I don't know what that means. Guys, I'm almost 40. I don't know what !Discord is. So hopefully maybe that worked, or maybe it didn't. Another thing to add to a suggestion for me to remember to do someday, because I've seen that people do that like once or twice before. Anyways, but yeah, on Discord would be a great place for questions like that. There you go. There is another invite there. Yeah, perfect. It didn't work. Well, when you get into the Discord, go into the improvements and throw that in there. That would be something I'd love to. I did it through your website. Perfect. That's wonderful. That should get you there just fine. All right, so back to this. So we've got our points that we're going to be pinning here. I think what I'm going to do is, well, okay. So we've got this group transferred over right onto our planar patch. I'm also going to grab another group node here because I want to pin the edges as well. I don't want those to hang down, right? So I want to kind of have this in a, sort of a, basically pin the boundary here. Now, maybe what we would do is make this even a bigger piece of cloth, like that could be something we do as well. So certainly if we took something like this and made this, say, 2 as a uniform scale instead, maybe that is more interesting. Maybe we'll try that. We'll do something like that just so there's a little more edge around it. And then we'll pin these boundaries. So what I'm going to do here is I'm going to change the group type to points. I'm going to change the group name to the same thing that I had transferred over, which is pins. So we can see here that we have a pins group. And so that's great. So let's untick base group. We're going to tick on include by edges, unshared edges, and that's going to grab all of our boundary edges here. And that's going to allow those to all be pinned. So the only problem is now we've lost the stuff in the middle. So when we do a merge here, we want to do a union with existing. So that's just going to combine them with anything that's already there. So there's our Houdini Hangout logo with this whole piece of cloth. I'm also going to transform this and see how this goes. So, okay, so let's hit enter, hold down control. That's going to snap it to certain angles. And you can actually change those, I think, in the preferences, I want to say, or maybe even in the display preferences here, maybe under here. Either way. So if you hit D, you can get into that, or you could go into your preferences and change that, I believe. Okay, so we've got this. The points are going to be pinned. So let's grab a vellum configure, if I can type. And we'll grab a configure cloth, append that there. So now this is going to make a cloth out of this, and we need to define our pin points, which are going to be pins here. Great. And that's really probably all we need to worry about at this exact moment. That will create cloth with those points pinned. And actually, if we zoom in here a little bit, we'll see that these purpley kind of colors these are ways that you can see where your pins are. Hey, Adriana. It's after midnight, but I have a beer making a party out of your stream. Oh, that's great. Thanks so much. I'm glad that this has been helpful for you. I know sometimes they're a bit random and just kind of scattershot, chats through this stuff, but glad it could be helpful. Yeah, I agree, Sudo. I always do like watching a good demo of Houdini. So anyways, here we are. We've got our pinned points here. You can see these little spheres. Hopefully you can see where they're pinning. Great. So let's do a vellum solver. Man, I'm having a real trouble typing tonight. Vellum solver. And then that should work for us there. Let's just maybe add some built-in wind. Let's maybe just add some wind in here. We'll do it in X, maybe 2. Just see if that gives us anything fun to work with here. And simulation, I'm going to up this a little bit just to make sure I don't run out of memory when I'm caching. And that should be good. Cool. Maybe I'll add a substep in there. And let's just hit play and we'll kind of see what happens here. And sure enough, we've got everything pinned down and sort of working the way we would want it to. I've got my time enabled here, and there's our cloth sort of doing its thing. So that's good. So we've got that working, so that's great. Now, I'm not really seeing any wind effects here, so let's just see if we can crank this up a little bit more, see if we'll see anything happening here at all. Now, obviously, we don't have any noise on that, so we're probably not going to see a whole lot. Let's see. Let's add this up to 10. Also, the built-in wind drag is at 0.1, which is a little low, so let's maybe up that a little bit more as well. Go to 2.25 there. Yeah, I think I'm starting to see it a little bit here. Cool. And let's dive inside. We're going to add a pop wind. Now, the reason we're doing the pop wind, just if you're ever wondering, is because vellum is a solver that works with points. And so any pop node is going to primarily work on points, or just exclusively work on points. And so those nodes are all able to add forces and things like that into our solver. So yeah, maybe instead of adding the wind up here, which is fine, we could do that. I'm going to untick that. And maybe what we do instead is just work with that in here. So we'll add a little bit of wind velocity back in here. Maybe I'll put my air resistance at like half. And we'll add a little bit of amplitude on the wind. Let's add some guides in here as well so we can sort of see what's going on. And I think, yeah, I've noticed that this has been happening recently. I don't know why this isn't playing inside of here. Interesting. Well, we'll turn that off for now. That's okay. So the few things that we're going to work with here mainly are like pulse length, swirl size, amplitude. We can play with roughness as well. So let's do that. Let's see where that gets us, just with a little bit of noise on here. We've got some stuff going on there. Cool. Let's maybe undo this. Connect the wind into forces. Yeah, you're totally right. Sorry about that. I wasn't even paying attention. Yes, it definitely should be in the force side. Good call. Thank you. I don't know why I did that. That was weird. I was just like, yeah, source, obviously. Brain fart. Yes, that's definitely where it should be. You're 100% correct. So here is sort of what we're dealing with. I am going to, I think I'd like to see some more, maybe some more like noise here. Let's see what we can play with here. So maybe the swirl size. Maybe we do the pulse length up a little bit and the swirl size down. I don't know. Let's try this. See where we get here. All right, and let's maybe do a little more amplitude here. Maybe 2.5. Yeah, it's starting to get there. Let's do maybe a little less there. Maybe a little more here. Cool. Let's do that. Yeah, it doesn't work there, does it? So, yeah, so one thing I should say probably is that if you run into stuff like that you feel like should be working, please submit a bug if you see that. I'm probably going to forget to do that after this stream just because after 2 hours, my brain kind of turns off. But if you see stuff like that, submit a bug because that is really helpful for all of our developers and stuff like that to have that information. So yeah, if you can do that, that's always super great. All right, let's see here. I think... yes, I do work at Side Effects. I work on the education team at Side Effects. I am not a developer. I do not make anything. I am just someone who helps instructors learn more about teaching Houdini. Okay, cool. So this is starting to look good and do something interesting, I feel like. Starting to get there. I actually want to play around with the... No, I don't think it's a feature. It used to work that way where you could see stuff inside. And honestly, if there's something that seems like it should be working and it isn't, even just submitting it as a bug can be good for the developers to know like how people are trying to use their software. Honestly, like we are encouraged to submit bugs. Now they don't quite always hold the weight that stuff does. Another weird bug of Houdini 20. When I use DOP network for my stuff, I always usually pin the viewport outside. That's interesting. Yeah, you could do that too. Sure, you could pin the viewport outside. But it should work actually in here because you're in a dynamics network. So like if you're here, right, if you go up one level, like this is a solve, like this is, you're in the network, right? So like all that's happening is we're in this one like sub network in here. So I wonder if that's the problem. I wonder if it's a sub network thing. This is actually the DOP network that's inside of there, right? So then there's all of these levels here. So anyways, too much information, but hey, Carlos, welcome. All right, so this is starting to do its thing here. I feel like I want to play around with this a bit. Maybe we'll let this stretch a little bit more. I don't know. Just kind of curious if that would be better or worse. I'm gonna actually really turn this down, see what happens here. And I think I'm just gonna put a little more amplitude in here just to see. Okay, that seems to be working. And let's look again if we pin these down and just kind of see what happens here as well. Yeah, that's not really exactly what I want it to look like. I think I want to change the rest length scale a little bit here. So let's see if that helps, if that'll help us kind of balloon up a bit more. It is cool. Too much though. So instead, let's do something like that. 1.05, something along that line. I wonder if I don't even need to have the stiffness change here. Let's just try this again. Maybe the stiffness was fine. Yeah, it's looking pretty good. All right, so let's do this. Let's take this down a little bit, see if we can add a little more resolution in here. Let's take a look at this and see what we got going on there. Okay, cool. All right, so let's just kind of see what happens here when we simulate that. Okay, cool. Yeah, so adding a little bit of rest length scale in here is going to help this kind of puff up and do some of these like weird little like pinching and stuff like that. Because what we're doing is we're actually telling it to not need to constrain these primitives, these polygons, to stay at that exact size. It's actually telling it to push them apart a bit more and kind of almost creating more cloth in this area. And that's allowing us to be able to kind of change the way that that is working. Now, from this angle, it's not quite really working yet because I want to see it a little bit more. So let's do this. Let's change the resolution of that. This might be too much, but we'll see. We'll see. Maybe we'll try 0.15. It said something here, performing Lloyd relaxations. I've never seen that term before. All right, so let's do that. And let's turn this down just a little bit like that. Cool. Hey, Crossfader, how's it going, man? Welcome. So, what we are getting here, let's just see. I'm going to turn on the point groups so we can see those, and maybe I'll can I make this invisible? I don't want that. All right, let me just do this. Group delete down here, and I'm going to delete this one just so I can see that. Cool. So the other thing that we should probably look at here is that those, there's a couple things that we should probably do, right? We should probably have those constraints around those points should be shorter in length, and we should be able to get that pinching a bit more. So that would be part of what we need to do here, because I think, whoa, that's funky. So we need to get these constraints that are surrounding these points to kind of stick to their rest length. So let's see how we do that here. I'm going to just color these maybe a little bit of a different color so we can see them a bit more. Yeah, there we go. That's good. Okay, cool. Those are the pinned points, so that's great. But what we can do is we can modify the stuff coming into here. And so maybe, so there's so many different ways we could go about doing this, right? We could just do it based on a group. We could do it based on a distance, right? To these points. And we could all do that internally within the solver. We could do that externally. There's so many different ways we could obviously kind of mess around with this. So I think what I want to just do first is get this working in sort of a static situation and then animate it, right? So let's just get it to a place where we like the way it looks static. And then once we're animating it, it should more or less do what we want it to. So I think what we'll do is, let's see here. Let me just put a null down and we're going to look at these constraints, right? Because these are going to be really what helps us control this. And maybe I will reduce the resolution of this just so it's not so crazy to look at. It is a bit much, but hopefully we can handle it. Okay, so we don't have those pinned points here, but we could transfer those over. We could... Yeah, that's probably the easiest thing to do. So what we have here is we've got all of these vellum post process. Yeah, for sure. We'll definitely do that after the fact here. So if we do a vellum post process, we can throw this in here. And we can... Oh, you're saying to see the pins, maybe? Maybe that's what you're talking about. Yes, definitely a vellum post process for... we can do a subdivision on this. And we could do that with like a loop since they're triangles. Could definitely get more resolution out of it. There we go. Right. However, we're not getting those really pinned in place nicely. So if we turn this down, we should have those more pinned in place the way we want it to be. Sort of. They're still a little soft, actually. Interesting. But yeah, we could definitely use this node to get some more resolution out of it. You know, when we're working at this resolution here, simulating it as such, then you can go to this resolution and get, you know, higher output of it. Anyways, so here, let's adjust some things because what we have is we have a rest length original and rest length scale, or rest length, current, right? So if we take this rest length scale and do it 1.1 and look at this again here, we should see, yeah, I guess it is just scaling them overall. I'm going to pin this down and just kind of take a look at what's going on here. It looks like those are both changing. So this is calculating the rest length, right? So why don't we do it this way? We'll take the rest length scale, set it to 1, and then for some of these other, we could maybe have like a sliding scale based on their distance, right? So what we could do here is, we could take the points here. These actually would, or sorry, just thinking. Would actually be maybe easier to, instead of transforming everything at this point, transform it earlier, because then I could just use these points here. Sorry, just thinking real quick. Yep, that's probably smarter to do. All right, so we'll do this. We're going to just slightly modify this. Let's do this in the XZ plane. I'm going to take this transform and just move it, I don't know, up here. It's good enough. Now we've got them set to be in the same plane, so that should work just fine. Cool. All right, so that's working now. So what we could do is we could take this and we could do a, distance from geometry here. And we could take this. Should be able to get a distance mask from that, I think. Let's see here. Geometry attribute. Sorry, is there a different one I should be using? Distance from target. No. All right, so this one, if we set it to primitives. Oh, yeah, output mask. Yep, that. There we go. That does work. I don't know why the distance one isn't working. That's really strange. Oh, okay. Yep. Sorry. I see why. Because it's for closed geometry. Right. The mask one is better. Thank you very much, sir. All right. So let's do that. We can do this here. And why don't we reverse this? Because we want it to be points. There we go. That's what we want. So I think what we're going to do here with this is everything that is, I think this is adding to, where's our mask attribute here? Oh, right. Sorry. That's why I'm probably not seeing it. Output mask. Mask is not being output. What on earth is going on here? Why is that not adding that? There it is. Okay. Sorry. Okay, so that's adding a point attribute. We can then just promote that up to our primitives here. So let's do that. Let's do an attribute promote. So we'll do this from point to primitive. We'll take the mask. So now we'll have this as a primitive attribute. There we go. So now this is set per primitive. And what we could do is even remap this attribute, right? So what we could say is for anything that's really close to those, maybe the rest length contracts. And then for anything that is further away, we could have that rest length expand. We can do all sorts of different kind of parameters here. So let's do that. And also maybe what we want to do here is, no, that should be good. That should be good. All right. So we've got the mask here and great. So let's try that. Let's do a, just do an attribute remap of this. And we can take our original name, we'll go to primitive here. And so we're going to remap our mask attribute. And right now it's either at, it's 0 to 1. And so maybe what we'll do is just play around with that a little bit. And where it's, instead of being 0, where it's that, maybe we do it like set 0.75 there. And then for the max, we do that at like maybe 1.1. I don't know, something like that. And the reason that we're seeing that color change is because this is set to a min and max. We could set this to an auto and maybe change the coloring a little bit. Maybe it's an infrared coloring or something like that, where we can see those values or whatever. So cool. We could just set it min and max. Yeah. Anyways, we'll just set it to auto. That's fine. Great. So now we have our mask that's going from 1.1 should be down to 0.75. And we can then take these Hello, welcome, La Pampadura. And then we can take these constraints and we can just let's see here, attribute adjust float. So why don't we just use that? We don't have to do any vex or anything crazy like that. We're going to take the attribute name, which is going to be a primitive attribute, and we are going to change that to be rest length. And let's just multiply this by a float attribute, and that is going to be our mask. And let's just do a multiply. And then that should be adjusting these values. So this should be making it longer in certain places and shorter in other places. So let's try that and see what that gets us. Let's just give it a shot. And there we go. So now what we can control here is the distance away for this mask, right? So if we go to here and change the radius, tighten that up a bit, that can change sort of how this is going to be able to interact. And so we just kind of need to play around with this, get it to a good value that will work. Mm-hmm. I think I need a little more geometry here to get some of these fine details in. So I'm going to just knock this down a little. Let that recalculate. Take a look at our distance map here. So the problem here is that it's kind of all or nothing. Is gravity applied? Yeah, that's I think yes, gravity is applied. We could certainly turn that off. But yeah, so I'm going to add a little bit more geometry in here. Take a look. Yeah, there we go. We're starting to get a little more here. It's actually surprising how quick this is, even though, you know, we're getting a decent amount of geometry in here. Yeah, maybe we'll cut this in two. Maybe we'll divide it by 2. Give it half the gravity. Maybe turn down the horizontal wind force a little. Maybe we do that to like 3. Yeah, there we go. Now it's starting to really get the logo going. Cool. And if we looked at this, this is obviously going to have even more geometry there, and we're going to see even better resolution of that sort of logo going on in there. Okay, cool. All right, let's see how this is looking here. It's a little too violent. It's getting crazy. All right, let's maybe turn that down a little bit. Maybe we do 3 and 2 there. And you know what I'm going to do? I'm going to turn down the pulse length even further. Maybe we do 2.5 there, just so that it's not going quite as nuts. And we can probably even turn that down a little more. Turn the air forces down a little bit as well. Take a look at that, see where we're getting here. Cool. All right, that's starting to work. Let's just turn off this group transfer and take a look at this without the logo in there. And you can actually see that when we have this whole stream going on here, because we're still calculating the rest lengths of those, it is still going to try to contract it based on that. So what I can do is just wire this directly in, and that should be back to its normal sort of cloth situation. Yeah, maybe we just turn the gravity straight off. Maybe we just do that. I always feel weird about that as a simulation, but like maybe it makes sense. I don't know. Results are getting interesting. Yeah, they are getting interesting. I agree. Constraints. So if you're not familiar with vellum, sorry, I'm just looking at this. It actually looks like it's going too slow now with the... Okay, I'm going to add a little bit of gravity. Maybe we'll do just a little bit of gravity here just to kind of help us out. So if you're new to vellum, the constraints, there's 3 different parts of this workflow, right? You have your actual geometry that's being like simulated over. You have your constraints, which are basically the way that we're kind of attaching these together to each other, right? If we didn't have constraints here, I think this wouldn't even solve, but let's just see what it looks like. It should just kind of go bonkers, right? It's just going to go absolute haywire because it doesn't know what to do with these points, right? It doesn't know how to keep them together. So if we need the constraints to be able to keep this in a cloth behavior, because really vellum is just simulating points and the constraints help to keep them together in different ways. In this case, we have cloth constraints. So if we look at, for example, if we do a null here, and take a look at this. Now, I've talked about this kind of at length before, but if you look here, we have distance constraints right now. So that's constraining the distance between these points. And so when we're tweaking those rest lengths, like over here, and we're changing these rest lengths, what that's doing is we can actually bake in that distance between those points without having them pinned down, right? So here, if we do this and do our vellum solver, since we're doing all these calculations on the constraints themselves, this is basically sucking it all back together, right? And so it's trying to keep those points in the middle now kind of tied together closely. It's not pinning them down vertically, but it is trying to keep them in relation to each other, pinned, right? Or not pinned, but try to keep that distance between them. And so hopefully that was why you were saying constraints, but that's kind of the 2-pronged approach that's going on here. We're pinning these as well, and that is allowing us to then get this kind of this type of a look here where we've got the logo and double the rest length beyond the geo. Yep. Yeah, I think yeah, let me tweak that a little bit here. So I'm going to do 1.5 maybe. It's probably a little too much. We'll do 1.25 there. Yeah, so we can obviously change the way that these are being controlled, right? So we can now go in here and tell it to pinch these even tighter here, let these sort of balloon out a bit more, and we do want to get these in here to still work. So let's see what we can't do there. Let's play around with this mask maybe a little bit more. It's tough because I've got these really close little sections here. So let's see how that looks. So, oh, thanks. I appreciate that. It was a labor of love to make the logo. Let's see there. That's starting to do its thing. So Zach was asking, is the attribute remap giving negative rest lengths? No, it is not. Yeah, that's interesting. We could maybe do that, add a force in the direction of the normals. Yeah, maybe what I would do there is actually just add in another wind or something like that, actually just pushing up. You could do it obviously with a wrangle as well. So I think that's getting to be too much. So Zach, your question is it adding negative values? No, it's not, because I'm trying to do this actually without using a ton of code. Just so people don't feel so intimidated by this. You can certainly do a lot of this stuff with, you could probably do this whole situation right here with one vex wrangle. I'm just doing it in a bit more of a visual programming way of thinking about things. But what's happening here is we're remapping it just from 0 to 1 as far as the mask goes, and getting the output minimum and the output maximum. And then we're using this node to multiply our rest length by the mask. So because our attribute remap is only going to 0.5 as a minimum and 1.4 as a maximum, it's either multiplying it by 0.5 or by 1.4. So therefore, you're never going to get negative rest lengths out of that. So let's do this. Let's just see if we can't, let's just do another pop wind here, and we can just wire these together like that. And I'll just say, we'll just give this up with noise, maybe something like that. Maybe we'll just do that. Yeah, give it a shot. Maybe do that upwards. Air resistance, I'll just match those together. It's 0.3. And maybe I'll just give it a little bit of noise in there just to give it something. All right, let's see if that gives us any help here. Yeah, definitely is. It's doing some fun stuff. So maybe with that upwards wind, maybe I'll just cut this in half. Maybe it doesn't need to be quite so high. Okay, that's looking pretty fun. All right, let's just add a little more resolution in here just to see where we're kind of getting with this. with this sim. So one of the benefits of doing this with a scaling factor like this with the yeah, no problem, Zach. One of the benefits of this, like of scaling it like that, is that as we change the resolution of our mesh, we're not going to run into any issues here with that because it's really only looking at, the rest lengths are being automatically calculated, and then we're just scaling them by this number. It's kind of arbitrary, so it shouldn't really change too much for us there. And honestly, we might even be able to pin a little bit less of this down. So here, when you're doing this, you could maybe even have this controlled like mathematically here, right? So this distance threshold could actually be, constrained to this. You could copy this, paste this relative reference here, and those actually, as you change this, it's going to kind of reflect it down here as well. And then that way, you're not going to be pinning quite so much. And maybe we do times 0.75 there, and maybe that's even better. I don't know. Maybe not. Guess it depends. Anyways, let's see what that looks like. Just kind of get a sense for what that looks like. Yeah, it's starting to do its thing. The only problem is I have so many like vertical lines or these kind of diagonal lines, you can almost not even tell what's going on there. But anyways, let me do this one more time, and I just want to see what this mesh is sort of doing. Oh yeah, that's right. Those are baked in there. Looks kind of cool too. There's all our constraints again. They're still being written in there, so that's something to keep in mind. So what we need to do is we actually want to kind of do two different things within our solver here. We're going to want to write these new rest lengths to these constraints, and we're going to want to pin those points back into place. So if we do this is just our standard simulation without any of those constraints taken into consideration here. We're just basically got a big flowy cloth, right? That's just going to be kind of moving around, doing its thing. And maybe for that, that's a great question, La Pampadura. Yeah, I've heard Houdini on Linux is fantastic. Tom, Waffle Boy Tom, always is that a what is that? Sorry, I'm just looking at that message there. That must be like a GIF or something like that. Sorry. Sorry, I'm looking at our chat in the Good night. Good night. Thanks for it's an emote. Okay. I was just like, what is going on there? It's not translating that over to my Discord server, so I'm like, what is that? Anyways, so we got this cloth going here. That's great. I'm just thinking if there's anything else that I want to do here. Okay. Another thing I think that we want to do with our geometries, I think we want to match animation here. I think. Because I'm pretty sure well, anyways, okay, let's think about this. There's a few different ways we could go about doing this. We could translate these pinned points back into position in our solver. We could do that. We could probably turn on their, well, let's just try that. I think that'll work if we turn that on. So if we keep it just that way, there's a couple things we'll do here. So let's do this. I'm going to take this group transfer over to here because we're going to animate this in, right? We want to keep this to be able to, you know, have that selection brought in after the fact. Or we could just set that to be a different group, actually. That would actually be smarter because then we don't have to bring that geometry in. So here, let's instead call this something like logo maybe. And then here we'll transfer over logo. And this is just going to be pins. So now our pins are just going to be that, but we do have our logo points as well set in here. Should just check. Yep, there's our logo points here. So we have a logo group created as well. So we should be able to now go inside of here, and if we do a SOP solver, we should be able to go inside of here, see our DOP geometry, which is this, right? We'll have our logo. And let's just do this. Let's just add in a switch here just real quick. That'll be probably the simplest way of doing this. We'll set this to be frame 24. So let's just say $FF greater than 24. That's going to resolve as 1. So as we slide through here, we get past 24. Didn't like that. Turn that on. Okay, so that's at 1. There we go. So it's switching over to 1. Perfect. That's all we needed to know. So part of the way that these points get matched is, let's do this. Let's set, we'll say attribute create, and no, actually, you know, sorry, we'll do attribute adjust float. We'll just say mass for group logo. We're going to set that to be 0 in this case. And so if we just type in mass, we should see that if it is in the group logo, we'll just organize those. So these are all the logo groups here, and we'll unfilter that. Oh, interesting. Logo. Okay. Okay, let's just do that work? No. Group. Right. Okay. Those are all the logos. Set always. There we go. So now these are all setting to massive 0. That's part of the pinned situation. I'm just like randomly pressing things here. So, okay, that works. We'll turn that off, Great. So this I think is just going to pin them into the place that they're at. So it's going to like halt them. That's not exactly what we want it to do. And there's a couple of things that there's a couple of ways we could do this, right? So let's do this. Let's go up here and just see what happens at frame 24. So we should have this moving around, and then at frame 24, we should have the logo pins or the logo points just stop. And there we go. So this is working. It's not putting them, though, into their rest position. It's just pausing them in place, right? So that's not exactly what we wanted to do. What we could do actually here is something maybe sort of clever. If we do I don't think this actually adds a rest in here, does it? No, it doesn't. So if we add in a rest position here, store a rest, and then come back in here in our SOP solver and put those back. Let's see. This should actually work. Maybe this is a bit too, this will be a bit too heavy-handed, but let's just see what happens when we do this. So let's extract the rest. And the only problem is this is going to do it on everything. That maybe won't work. Okay. Yep, that won't work. Never mind. I thought I was being clever, but we don't have a way to set that on just a group, and I don't think splitting that and merging it back together would be smart. I think that'll cause some weird stuff. So, okay, trying to be clever. I don't think that'll work. So let's try this instead. Let's do this. We know that this pin to animation should match whatever is here, right? And nothing's animated here, so it should just pin in place. And that's glue to animation. So we need to set that to 1 maybe instead. So let's give that a shot. So let's come in here. Let's do attribute create. We'll just say for that group logo, we're going to say glue to animation. This is a integer. We're going to set the value to 1. The default is 0. And that should do something. So let's see. Let's see if that will snap it back into place. It might not. Give it a shot. See what happens here. Probably could have just done this at frame 12. That'd been maybe smart of me. But anyways. There we go. Okay, cool. So we're getting somewhere here. So what I'm doing there, right, is I'm telling it to match those points to their animation, right? So that attribute is something that's known to the vellum solver, and it knows to then snap it back to this position that it brought in. And in fact, there might be a little hint that this knows where it should go, because I bet you there is a rest in here somewhere or something like that it knows. Maybe not. I don't know. Just looking to see if there's any attributes in here that it can pull from. Not seeing that. That's interesting. So it's something that is just inherent, is just built into into the solver that is knowing how to do that. So let's take that and maybe go a little bit further with that, and let's calculate some other things, some other attributes with this. Just trying to think exactly how I want to do this. So what I'm thinking that we might do here is so we're going to need to add these in here as well, but this is actually going to go into its own separate solver, because this has to work on the constraint geometry stream in our vellum solver. In fact, I might just turn this down a little bit again, just get a little less geometry, just so this can process back and forth, can go a little faster. There's our group transfer. That seems fine. Cool. Okay. So, I'm just trying to think of what the best way of doing this is, because we have this logo, right? And we sort of just want to have it travel along each of these points and have it slowly kind of pin itself down. There's a few different ways we could probably do this. Okay, so let's do this. Let's get out the curve U, curve number. Yeah, that works. Let's do that. So we've got our curve number and our curve U. What we can do there is we can, let's just do a point wrangle. Do something a little scary. Get a point wrangle going. Let's do this. What do we want to call this? Maybe curve. What attribute do I want to call this? Curve. We'll just say like curve distance equals at f at curve U plus f, or no, that's an integer, right? Yeah, I think that's an integer. Just go back here. All right, that's an integer value. Yeah, of course it is. There's no decimal. Plus I at curve num. It's probably going to yell at me because that's an integer. But let's just see what happens here. Curve distance. Look at that. Didn't even have to yell at me. Thank you. So great. This is great. This is exactly what we want. So this can give us a curve distance, kind of a distance along the curve, right, for each of these. And if we look at this, we should be able to visualize that maybe. Let's see here. Curve dist. Let's see how we can do this. Let's do auto. Let's do extract all points. Let's just do this as an example. See if this will let us visualize it a little better. Not great. Anyways, what we're doing there is, let's go here. Let's change this to a marker. Ugh. Don't love that either. Yeah. Anyways, what we're doing is we're going to be starting it from 0 here, and it's going to go around, and then it's going to start doing this over here, and then it's going to do these smaller two ones. We could sort these as well because it's 0, 3, 2, 1. Yeah, so let's do that. Let's actually sort these as well so that we can get these. So let's do a sort here. This should affect the numbering for how this goes. Let's do a sort. No change. Primitive sort by X. There we go. 0, 1, 2, 3. Perfect. So does that change this? Looks like it does. So this is 0. Now we're in the 1s. These are the 2s, and this is 3 here. So what I'm going to do with this is let's do an, we can just do a, let's just do another attribute remap here. And we can use this to set up the frame numbers that we want this to go over. So let's do this. So we'll take curve dist and we'll call this we'll say active frame. So we're going to make an active frame attribute here, and we'll say we'll start at 12 and we'll have this go to, goodness, maybe 96. I don't know. No, that's too far. Let's do 72. Maybe we'll try that. So we'll do that. So we'll have, sure. I feel like there's something weird going on here where we're getting these weird values. Hey, Gustavo, welcome. Well, let's just give this a shot. It's not gonna hurt anything. Yeah, let's do that. We're gonna have our logo here. We've got this all happening. Whoa, hello, turn those off. Okay, so we need to attribute transfer that as well. So we'll do an attribute transfer. And what we need to transfer is from here. And we are going to transfer the active frame to these points. The distance threshold isn't really going to matter because we're going to transfer based on the destination for logo. And that is going to be a points group. We just set those both to points. And we should only have the active frame being set on the logo. So if we turn this on, these all will have active frame numbers, which is great. It shouldn't really matter if we turn this down. I mean, basically the second it turns on, it's going to just get the closest one anyways. So that's good. And what we should do as well is we should just give that a sorry, I'm just thinking. That shouldn't matter. We're just going to be working over those points. I was thinking that having, sorry, I just answered myself out loud. That was weird. I was having a conversation in my mind and said it out loud. So the active frame, if it's at 0, it doesn't really matter because the only ones we'll actually be iterating on are the ones that have values. So it kind of doesn't matter. You'll see that in a second. But this way we're not writing, we know which ones have values basically. Kind of doesn't really matter in some ways, but okay. Great. So we have these active frames here. And so what we can now do is we could go inside of this vellum solver again. And instead of doing this switch here, we could do a couple things here with a wrangle. I think that's going to be the easiest way to do this. So again, we're going to do a point wrangle. Now the reason we're using a point wrangle and not some sort of weird DOPS node is because we're in a SOP solver here. So we're actually solving this SOP geometry every frame. We're calculating what's going on with this SOP geometry. So this is just a normal SOP world. We're not anywhere weird. We've gone from we're inside of a DOP network working in SOPs again. So we've kind of come back full circle, right? So don't worry too much about what's going on here. So here's our point wrangle, and we're going to say, yep, we've come full circle. SOPs and DOPS, they're a never-ending loop. We could do this as well in a pop wrangle. That is totally possible as well. And the reason I was doing it, so let's do it this way, and then we can also look at the pop wrangle and understand what's going on there as well, because that could be maybe simpler for you to understand as well, just to see the difference. But this will work fine, and that would work fine as well. Just slight difference in how you're doing it. So we're going to work over just that group logo. Let's say if, let's say at frame, which is a, let me make that bigger so you can see what I'm typing here. So that is just a standard vex argument or whatever that you can just use, and that'll return the frame. So if the frame is greater than f at active frame. And the reason I don't have to do anything in front of frame is it knows what that is already. So it would be an integer value. No, it'd be an integer value, I think. Anyways, so if that, sorry, I don't want to put a semicolon there. So I'm going to just put my brackets there. That's how I like to do it. You can do it your own way or whatever. But anyways, if frame is greater than active frame, so if our frame has gone past when we want this to activate, do it. Because our active frame is, like if I change this here, our active frames are fractional. It's going, when it gets to 36, frame will be greater, right? So we don't want it to be when it's equal. We want it, because equal is tough when you've got, float numbers and things like that. You're never going to hit right on. And trying to round it to integers, there's no real reason to go into that. This is basically doing the same thing. So that should work just fine. So let's do the same thing we were doing over here, right? We're just setting mass equal to 0. So let's come over here and say f at mass is equal to 0. And then the other thing we're going to do is glue to animation. So we're going to say I at glue to animation equals 1. And that should be all we need here. So let's just do this. We'll wire that right in the output. Nothing else is really going to matter here. And let's see what happens. Maybe it'll work. Maybe I did it right. I don't know. We'll see. Yep. Looks like they're gluing down. Whoa. Interesting. Why did that happen? Oh, I bet you I know what I did. Yes. I didn't change the input max. That's my problem. So at one point, they just all go to 72. That looks ridiculous. Okay, so let's change that a little. What's our maximum here? It is 4. So we'll change it to that. That's silly. Maybe we'll speed that up a little bit. Maybe we'll do it to 48. I don't know. Let's change it like that. See how that goes. Oops. So yeah, so it was just going past this output max, and once it got up past 1, it was just like glue everything down, go. All right, let's see how this works now. Yep, it's doing it. Yeah, it's probably a little too fast, so let's change that a little bit. So the nice thing here is that we're really just dealing with some remapped attributes, things like that. So once we just adjust this remap here, we'll be able to just replay this, and it's just pulling those values in. We know the sim is going to basically take the exact same amount of time there, so that's kind of nice. And this is going around doing its thing. Cool. Looking good. So what we are going to want to do here is a couple of things. We need this to now make that sort of, it's pinning it down, right? It's gluing it into place basically now. So we're probably too fast. Yep, way too fast. Let's adjust that a little bit. Let's set this up to maybe 96. And the interesting thing here is that it's not really super smooth. Why is that curve? So the problem that's happening here for some reason is that this curve U is sort of being a little weird, and I'm not sure why it's doing that. Sure. Is there a measure that I could use? Would this work? Maybe. No. Oh, wait, hold on a second. Perimeter length. Why is that not giving us a good curve view? Not sure. I am not sure. Maybe that would work better. Let's see. Let's see where that gets us. All right, let's try that. Resample by polygon edge. I don't know. Maybe that'll work. Let's give it a shot. All right, so let's come down here. I'm going to turn these off. Let's just see what this animation looks like. All right, let's just play that back and see. Way too fast. Still way too fast, man. All right, so I just thought of another thing that could work. Instead of doing it this way, maybe the best way of doing this, let me uncheck this, is to take the point numbers and so if we do this, sorry, just thinking here. Let's do an enumerate. It's going to get us all of our point numbers here. And if we take that, let's grab this PT dist, enumerate. This number should be really close for each of those. So I wonder, could we just do this instead? Could we take the index, multiply it by the point distance, and get that? Let's just try it. Let's just do this real quick. And then we'll say f at curve dist equals I at index times PT dist. And I think in this case, we're going to need to change that because oh, that's fine. So our numbers are a little different, but we can work with that. So the last one is like 7.06. So that's kind of perfect. That's great. So what we can do is just change our attribute remap here to be like 7.06. And then now this is going to be our active frames, and that should be a lot closer. Let's try that. Let's see how that works. So this should be a much more linear remapping of this. And so, okay, turn off those. So this should hopefully look a little better. And one other thing we could probably do here is, I'm going to just check that to none, but I wonder if we could do, can we do this? Pin to target or something? Will that show those points? Sure does. There we go. Now we can watch them get pinned. Just a little easier to visualize it, maybe. Oh, that's weird. Why is it doing it that way? Okay, interesting, interesting. So the only problem we have here now is that these points are slightly out of order. It's fine. We can make that work. Okay, let's see here. Oh, we can just, let's take this, move it down here. I could use a carve for sure. But yeah, you could use a carve. You certainly could use a carve. Maybe a little too far into it right now. But yeah, you could probably use a carve. The only difference there is that you'd have to change the logic a little bit within the solver. I'm just going to try this really quickly because I think this is going to work. So point sort by attribute. The attribute is curve U. Did that even do anything? Let's see here. Sorry, I just want to look at this, see why. See if this is not. Is this not matching up? It is. Okay, that's really weird. I thought that would work. Okay. Yeah, let's give the carve a shot. I do like this method a little bit, but you know, hey. Here we are. All right, let me turn those off. So with a carve, let's just see how this is going to look here. What is it doing? It does look like I have two splines, maybe. But I don't understand. Yeah, let me check that out. Points, vertices, polygons. That is really strange. I do not understand that. Yeah, let's try that. Fuse. What? That is crazy. Let's just check something out here. Let's just blast one of those primitives. This one, sure. Delete not selected. Carve. Oh man. That's crazy. I feel like I'm losing my mind. Yeah, I'll try it. That's carving all of them. We all lost our mind. Huh. It should be working. Yeah, so if we do a... This is interesting. Connect path, carve. There we go. That is so weird. I do not understand what is happening there. Like why that happened. Oh, interesting. Look at that. No, that's not. So if I do the connect path, extra vertices, but that's probably because it's open actually. Yeah. Will that work? No. Interesting. So does this only work with open curves? It's interesting. I did not know that. What is the way that we do that so that it is so all of them carve sequentially? There is a way to do that, right? Ah, yes, I forgot about polypath. That is what you want, I think. I mean, it's basically doing the same thing, I think, but why is that not? Um, right. Okay. So Rob, I'm definitely seeing what you're saying there. I'm not sure how that's going to work with the carve though. Right. You probably have to for each them. I really thought there was a way to do that. To carve them. Must be thinking of something. Target points parameter. Copy to points. Yeah, what does orient along curve get me? Does that get me anything different? All right. So I'm down a rabbit hole for kind of no reason right now because it was sort of working. It just wasn't going at the right speed. So I'm going to get this whole thing figured out first, and then we can go from there. So yeah, that's what I'm going to do because I'm just getting down a rabbit hole here of thinking of different things. And really, it was working at a certain point here. It just wasn't going quite the speed I wanted it to, but that's okay. I can just live with that for now. Feel free to go in and adjust as as need be. Let's see here. Where am I? Point distance. Is this doing the curve distance? Yeah, rabbit holes are definitely part of Houdini, 100%. Sometimes it's just knowing when you should go down them and when you shouldn't. And right now, I just want to make this work, I think. So I'm going to do that. So we've got curve distance, index point distance. That was working fine, I think. Oh. Duh. I could just do this. I could just... Duh. I don't need to do that. I could just do this. Could take a fit I at index, comma 0, comma at numpt, and then put in the values I want here. And don't even, or no, you know, I could just do a 0 and a 1 here just to normalize it. Right? This will normalize it out from 0 to 1. I'll do numpt minus 1, I think, actually. Yep, because that'll put the last one at 1. Great. Let me just make this a little smaller so you can see that. There you go. Okay, and then we can just do this. We can do curve distance. We can do the output max of 1. That's fine. And now we have active frame. should be nice and normalized across. That looks like that might work. So let's see. Let's see. Did I just go back and hopefully do something reasonably okay? Thank you everyone for your suggestions. Rob, you made me think about how the fact of the matter is that I can just use the index numbers and not have to do really. Okay, I just hit the end one. So thank you everyone for your suggestions. That was wonderful. I think this might do exactly what I want it to. So I think we're going to be okay. I was doing some weird jumping there, and that was because I was using the point distance for some unknown reason why I thought that was a great idea, but it wasn't, clearly. So this should work. I'm not going to have any weird jumping. All good. It's going to draw the logos. There is no I in team. That's true. But thank you, Rob. I still appreciate it. All right. So that's going to work. I could order them, the point numbers differently. Probably what I should do is, where was that sort? Where did that go? Because here we've got the index. If I do the, let's see, if I sort this one more time, sorry, I'm just going to do a sort here, primitive sort by X. That doesn't change my, by primitive index, I think is actually what I want. We'll do this, and then if I do this here, primitive index, no change. Does that do it? Yes, that does. That's great. Yeah, but crossfader, that makes you, apparently that might make you an a-hole. So that's why there's no I in team, because it just makes you an a-hole if you do have an I. All right, that should work. It's good stuff. All right, so that should be all great, all good. Okay, so the just trying to think here what I want to do with this. Because I want to attribute transfer that value over as well. Let's see here. So let's change this rust length scale. We changed that to 1.4 as at its maximum there. So let's do that here. Let's do 1.4. Actually, probably should have been visualizing that to begin with. It's a little messy in the middle there. Let's see. Can we give that a little extra oomph upwards maybe? Well, it's not really reading properly yet, but let's see. Let's see if we can't. Let's see if we can't make this a little nicer. All right, so we need to transfer these rest lengths over as well. So let's see if we can't do that. Just thinking about what the best way of doing this is. Maybe instead what we do is we do this at like 1.2, something like that, and let it balloon up a little bit more. When those get like stuck down or something. Okay. Even that might be a bit much. Let's try this. Okay, so we have our logo here. Let's also attribute transfer that over as well. Drop my stiffness. That's a good point. Thank you, sir. My stiffness is quite high. Good point. Thank you. Forgot I turned that way back up. And honestly, I wonder if I could even bring the bend stiffness down a little. All right. Yeah, we're probably getting somewhere there. All right, let's do that. Let's go down a couple more steps with the stiffness. See how that looks. All right, so let's take a look at the transferring this over to get those constraints to be able to move. So let's do attribute transfer. We'll do this and this. I'm just going to kind of transfer those. Yeah, it totally. The stiffness is I always forget about stuff like that. The little adjustment in stiffness is what you need. All right, so let's transfer over. What is it? Active frame. And I think, let's see here. How can we visualize this? So this should be adding it to the points. So let's go in here. Let's do auto. Interesting. So that is what we're getting from this here. So what we can do is we can change the distance threshold here a little bit, maybe. No, it's going to just go like that. Do we get any blend width? There we go. We'll do some sample counts, just to sort of blend that out a bit. We don't need to worry about the distance threshold, I don't think, because that's just going to control. Yeah, it's not going to matter. All right, so let's just do this. Blend width isn't going to matter. Maybe something like that, just to get a few extra samples in there so it's not so rigid. Yeah. Let's try it at like 5, something like that. All right, so there we go. That's going to be all of our active frames. So that's when we know we're going to activate these primitives. I'm just going to attribute promote that as well, active frame, because we want that to be on a primitive instead of on the want that to be on the primitive instead of on a point, because we're working on primitives here. So let's do this. Cool, attribute remap, that's fine. I got our rest length. Let's put a null down here that we can reference in. Just gonna shift this all over. Maybe something like that. Just trying. Whoop, hello. Just trying to make this a little more neat. All right, there we go. So we've got our active frame that we're transferring in there. Great. We're going to say, let's say target. Target cons like that, just so we can have that shorter. Great. So if we go in here to the vellum solver, we can also do a SOP solver constraint geometry, I believe. Yes, that you could actually do, but actually, sorry. We're just going to do another SOP solver and just change the data name. So we're just going to change this from geometry. If we open up our vellum object, we can look in here and see that there is a geometry, and there's also a constraint geometry. So if we take that name and just add constraint in front of this, like so, go inside, and now we have all of our constraint geometry here. And so what we could do is in here, we can object merge in that. Where is it here? Oh, I'm one too low. There it is, target constraints. So this is all of our constraints here. This is going to be oh, actually, you know what? We don't even need to bring that in because we have our, I know we can do, sorry. Instead of doing it that way, let's just come up here and we can change this to target rest length. So now we have our target rest length. We'll say target rest scale, sorry, because this is our target rest scale here. In fact, it's just our mask, so we don't even need to do this. We can just take it here instead. So let's do this, target rest scale, just to get one less attribute. We don't even need this anymore. So let's just do this. Now we have our target rest scale, and we can actually just wire this right back in. We don't even need to have this as a separate thing that we're referencing. It's really all we need to do. So we can get rid of this because now we have that information in here. If we go back, just make sure that this is all reset. All that is cached, hopefully. If we go inside of here and go to our constraint geometry, we should see that we have, we'll just do this, target. We have our target rest scale in here. And so what we can do is when our active frame does this, it's basically the same exact thing we did up here in our point wrangles. So we can just copy this and come back in here, do a primitive wrangle. Not that it's a huge difference, but we'll just set it to primitive. So here, so if our frame is greater than our active frame, what we're going to do is something in here. So we'll just get rid of this and we'll say f at rest length, and then we'll do our times equals, which just means multiply it by this specific, value. And we are going to use, our, what was the name of it? What did I call it? Target rest scale. I'll just copy that in, go back in here, times equals target rest scale. So we'll say f at target rest scale. So this is if the frame is greater than or equal to the active frame, the f at rest length times equals target rest scale. So this means we're going to multiply the rest length times that scale inside of the solver live. So we're going to be doing this all in our solver here. So let's do this here. Cool. Great. All right, let's see what happens. Fingers crossed. Oh, nope. Oh, right. I forgot. What we need to do is not do it that way, because you're going to be multiplying it every time. So they're just going to be growing crazy. So what was happening there is, because we're doing this in DOPS, every time frame or every time step, we're multiplying it by that value. And that's wrong. Shouldn't be doing that. So I'm just going to mute this first, or, bypass that for a second. If we look at our constraint geometry output here, I guess, let's just grab this null. We can just take a look at this here. What I think we should be able to check out rest star, and let's just see here. If we look at the constraint geometry. Oh, I should just be on this one. What am I doing? Okay, so we have our rest length and rest length original. What I should be doing is changing the rest length from the multiplication of rest length original and rest length scale. So we should change this just slightly. So what it should be is rest length equals f at rest length ridge times, there's some long names, sorry. Let me just make that a little smaller so you can hopefully read it. Rest length or ridge. I think that's right. Okay. Now let's turn that off. Nope. Typo. Rest length or ridge. Nope. God, I can't spell. Rest length. ORIG. There we go. Jeez. Spelling. It's a real thing. All right, let's try this again. See how this works. We should see that these rest lengths will change and just stay at a nice rate, basically, and not go bananas. Actually, they're getting too long there. Interesting. They're going crazy. Okay, so what I'm going to do instead is we're going to do a little tweak here. So we're going to change this because now I'm realizing that we're multiplying it times this rest length scale that already exists. So we should be doing it this way. So the maximum output would be 1 because we don't want any of those to actually get any longer than that original value that we're setting it to. So that should now start to do what we want it to, I think. Yeah, there we go. Well, good. I'm glad. Yeah, I don't. All right. So we're kind of there. So one of the cool things we can do here is we can tweak some stuff here with this remap up here. So I actually think it's still going a little too fast, and I'm going to change this to start at 24, so it's got a little bit more time to get into place. And let's do this to 168. And what we can actually come over here and do is we can now do this with a Bezier, and we could just, oops. What did I do? What have I done? Let's just do this to 0. Hello, there we go. 0, 0. Just extend that a little bit. Extend that a bit as well. And so now we're actually changing the values here for our active frame. So as we change this here, we're going to be tweaking our active frame values, and we can do some fun stuff there. So we could actually set this kind of however we choose, however strong or weak we want that kind of easing to be. So now as we come down here, we should be able to actually have it ease in a bit more and ease out at the end. So it's not just a linear animation, and it's just from that one attribute that we're changing. Actually, you know what? I think I did it the wrong way. I think it should have, the easing should have gone the other way. Because this is all going to snap right at the end, I think. We're going to get this thing, it's going to speed up, speed up, speed up, speed up, and then snap right at the end. Yeah. So it actually is the wrong way to have done that ease, but that's okay because it goes boom like that. So it's too much. So what I should have done is taken this and instead made this a little bigger and made this curve like this. Oops, let me just go back up here and do this. So if we do something more like this and like this, this is actually the way we want this curve to be, as weird as that may seem. Something more like that. So that'll start out slow, speed up, and then end slow again. So then it's going to go real slow, kind of draw its way around. It's going to start speeding up. And then these will get faster here. It'll be kind of scribing that in. So what I think I'm going to do next week is I want to add one more thing to this. I kind of feel like it would be really interesting to add a way to make color on this for my logo, right? Because it would be I'll probably play around maybe a little bit with this simulation and get it in a little bit of a better spot, because it feels like, yeah, I agree, Zach. So Zach's just is saying how you can remap it and do some cool stuff there. Yeah, I totally agree. So here it's just going to go blunk, and then it's going to go faster there, do all those real quick, and then kind of slow down there. So you can really tweak this kind of however you want to. This is, I mean, you could do that obviously with a carve too. I mean, there's so many different ways you could do this stuff, right? So I don't think there is one specific way of doing this that's going to be better or worse or whatever. Like there's so many different options to kind of play with and get into here. Let's just reduce that a little more, see if we can't get some more interesting resolution in there. All right. Another thing you might want to do is add a little bit of like drag to this maybe too. That could be kind of cool to do, just like add a little bit of drag. One more thing I'm thinking of here. Just trying to think if this would be any better to tweak this. I'll just see if that helps at all. I don't know. Don't know if it will or not, but we can play around with it and see what happens. Hmm. I almost feel like what I should be doing is almost reversing how well, I have some thoughts, but anyways, I think we're getting somewhere kind of interesting here. I think this is certainly doing what we were sort of hoping it would do. Um, I'm kind of thinking that with the way that my logo is, that you might actually need to, it might actually be better to constrain everything inside of here and everything inside of here and everything inside of here, you know what I mean? And not have it only pinned on these edges like that. I almost wonder if that might be better to do. And we could do that. Yes, I think we could do this. Let me try one more thing here. So this is setting the active frame. This is setting the logo group. So what we could do here is do remesh for this. Sorry. Just do that to get some points inside of it. Do that. Let's see here. We're just going to delete this channel and just kind of freehand this a little bit. Okay. Active frame. Just want to visualize that. Let's see. Do we have an active frame? Okay. Okay. Interesting. All right, let's see this here. So this could probably go back. Could actually just be from primitives. Something like that. How is this looking? Active frame. Okay, that seems right. All right, let's try that. That might be all we needed to do. Maybe. We'll see. I might have broken everything, but let's see. Yeah, it's working. It's doing its thing. Yeah, maybe it's not as interesting. I don't know. Maybe it's, yeah, maybe it's like you just want it to be not pinned in place, but maybe just like Yeah, I don't know. It's interesting. I mean, it's not perfect, but it's something. Yeah, it's something. It's like a different way of doing it. And I wonder if instead of doing it that way with the pinning, so I kind of am wondering, honestly, what this would look like if we turned off the pinning part of it and just had it do the constraint geometry side of it. I think that could actually look kind of cool. Let's just see. Let's just see what happens. Procedural knot generator. Caden is asking if I've tried to make. No, I haven't tried making a procedural knot generator. I don't even know what that for ropes. Oh man, I haven't really thought of that. It's interesting. It's going to be interesting. I don't know what this is going to do. Could be cool. Could be really stupid. I don't know. Well, it's weird. It's definitely weird. It's like an alien shower cap, maybe? That's what I'm going to call this. I should have named this stream Alien Shower Cap. Oh, that's weird looking. Yeah, I don't like what's happening there. It's freaking me out. It's freaking me out. I mean, it's weird. Don't get me wrong. It's really weird. So probably what would actually be better here is having, instead of pinning these constraints, having a soft constraint. Here's the question though. Does that change anything? Sorry. No. Is there anything in here that it's doing? Oh, alien shower cap to pinned. Ah, I see. Yeah. Yeah, maybe. Let's see here. This is permanent. What if this is soft? Permanent. Soft just adds a rest vector in there. Doesn't really do much of anything that I can see. What about this here? Geometry, active frame. Near the end, I make a pair of sandals just by tying knots. That would be fun. What would this do? I'm not even sure what this would do. It's going to work. Oh, right. I turned off this anyways. Yeah, so what you could do, for sure, is we could do something really interesting here. So let's think of this. So you have these attributes coming in, right? So all you need to do if you want these to offset is to offset the time of those, right? So if we take our, what did I call that? Active frame. So if we do attribute remap. No, sorry, actually, we could just do an attribute adjust float. This is an easy enough thing to do. We'll just grab our active frame here, and we could just add a constant value to this. So if we wanted to offset it, say, by 24 frames, let's just say, our active frame is going to be offset now by that amount. So if we come into our vellum solver and let this play out, it's going to start to do those constraints first, and then 24 a whole second later, it's going to start snapping those into place. We could do it that way. Another thing, oh gosh, there's so many things you could do here. Another thing you could do is you could pin them into their constraints, but then also you could only pin the border of it, maybe. Okay, hold on. Let me cooking here. Let's see here. So this is our, what am I visualizing there? Right. Let's just leave that at permanent. That's fine. So the distance from geometry here should stay the same, even if we don't remesh this, right? Yes. Okay. So now if we come over here, that should still be the same like that, but this is going to be where the constraints are smaller. And so what we could do here now is we can, this might really work. Actually, this might work really well. So what that's going to do is keep those constraints tight, but like it's going to constrict that fabric there, but it's only going to pin it around the borders of the letters. So this is going to start kind of doing its thing, constraining in. It's going to start pinning those into place, but it's only going to pin the border points of those of the logo down. So the rest of it will have some room to kind of flex and do some stuff here, right? So it's not going to be perfectly pinned in place. So that could be a really interesting thing as well. So that's just pinning the borders. So maybe what we would do there is, okay, hold on. There we would change the remap to be maybe like this. So hold on. Let's actually turn this off for a second. We won't have it be offset right now. We'll just have it go in simultaneously so that it's pinning and readjusting the constraint geometry at the same time. So let's see how this works. No, it's too big. Went a little crazy there. So let's try 7.5. So I'm just trying to kind of figure out what the inside value of that is going to be, because now we're not constraining, we're not changing the length of everything that's like close to those outlines. We're changing everything that's close to that's bounded in the primitives. So this should actually allow us to reduce the rest length scale inside of that. Yep, there we go. Let's see how this works. Yeah. I think that's more of the answer there, where we're going to have a little bit more interest in general. We've got a little bit of movement inside of there, and the big spots, the big areas there have a little bit of room to move around, but the smaller ones are pretty constrained, and the interior where there is no logo is just totally loose and free to kind of move around however it would fold and move or whatever. But that, I think, is more of what we want. I think that's kind of the play right there. So obviously you could go through and tweak that. So I have some ideas for adding color to this, and I think that's going to be next week that we're going to get into that. I kind of want to maybe play with some vellum fluid and see what we could get into with that. See where we could end up. I think it could be really interesting, and it would definitely give us some more visual interest here, I think. Yeah, it's pretty fun. It's maybe a little too fast, but that's okay. That could be played with. And maybe it's still a little loose in these little areas here, but I think it's doing its thing. Cool. All right, guys. Well, I think that is going to just about wrap us up here. If anybody has any other questions or anything like that, or any thoughts, feel free to put it in the chat. Caden, you had suggested procedural knot generator. If you have any examples of what that could maybe look like, I'm not exactly sure what you're thinking with that, but that does sound like an interesting thing to think through. So yeah, maybe you do that and throw that in the Discord server. If you're not in there already, you can go to HoudiniHangout.com for a Discord server invite. And and this file will be up on the on a Google Drive link that is on the Discord server as well. And if you're interested in checking that out, you can get a link to all of that on the Discord. You can get access to the Google Drive link, and this will be up there in 10 minutes, whatever. Thank you guys so much, Crossfader. Thank you for the inspiration. Like I said, I saw it a couple months ago. Actually, might have been traveling when I saw it, and I was like, I'm going to, I really like to play around with that. So, thank you for the inspiration and for coming and hanging out with us all. Your render is wonderful. Very nice job. So maybe we'll put this together and get something interesting from it. And maybe we'll see this in the intro at some time soon as a little logo thing, especially if I can get the color in there. That would be really fun. But hopefully this gives you a good idea for how you can tweak your constraints, how you can pin stuff, how you can mess with things inside of a solver. There's lots of options that you can have when you're working with a simulation to kind of drive it in a way that's interesting for you. And like we were saying, there's always more ways to do things. There's some really, you could do things with carves. You could do all sorts of different things, whatever works for your, for your situation that you're in. So, I think maybe next week we'll get into that a little bit, doing some lighting and some. First of all, I want to get some color on there, so I want to do something with the. Maybe with some vellum fluids, like I was saying. I think it could be really cool. This might end up being like slightly tilted so the fluid runs down it or something, but I'd really love to see the fluid interact, I think, with the cloth. It could be really neat. And maybe that paints the color on with the fluid, do like a little wet map type thing. Cool. Well, thank you all for joining. Thank you so much for all of your suggestions and help along the way. Sometimes there's little moments where it can... your brain can shut down, and it's nice to have a little bit of backup. So thank you all for being here to be a part of the stream. It's not just me doing this stuff. Obviously, everybody's, in there helping out and kind of talking us all through it. So thank you all so much. And that's it for this evening. And I will see you all next week. Thanks from... Great outro. Thanks all so much for joining. And next Wednesday, we'll see what we can get up to. Maybe add some fun stuff to this. Talk to you all later. Have a wonderful evening. Thanks, everybody.